So this here will be hopefully how to build a robot. So these two kits here are the NXTs, and I have a kit back here. I think you can see it. It's an EV3 kit, the base model kit that my friend Zach graciously lent me to make this video. So thank you, Zach, for watching this. So I've made these kits. I printed out the package containing the expansion kit and the EV3 kit, and I've tried to match the pieces as best I can, but these two do not have all of them because I don't have most of the newer parts, but I'll make do with them, with what I have. So and this one has all the EV3 components, like the motors and the sensors and the XT brain, or EV3 brain. So basically every part that your kit has, these I have and what I'm building with, but less. I'm building with a couple less components. So the brain, and I will get these boxes out of the way. So a couple of things to be familiar with when building a robot is really it depends upon the competition field, but those things generally make the robot about the same. But the most important is looking at the field, determining size, what size to make your robot, because that does matter. Although the beginner model that they first gives everybody, or that Lego gives out in the building books, it is a good model, but it does have its upsides and its downsides. It could be stronger, could be smaller, or it could be bigger, depending upon what you need. For this, for the robot that I'm going to build, and for what I think that would be good for this year, since it involves climbing and it does involve some pretty tight quarters, would be a smaller robot. It's a little bit more challenging to fit everything you want on there, but sometimes what you want and what you need are two different things. So it brings up a good principle of, it's an acronym, it's called KISS, and it's keep it super simple. There's many different ways to say it, but its main meaning is you don't have to make something so complicated that it hurts your head when you look at it. Sometimes, and most of the times, the most simplest solution is the best. Same with the robot. It's really easy to make a mistake or make a big robot, but you quickly learn that could be a really bad mistake for many reasons. When you're actually making a robot, the axles, let me grab some axles here. Well, I'll get to that. So we've talked about size is one of the things to look at for your robot, but another thing would be it would have to probably be what you want to attach to it. That would also matter. Do you want 4 motors, 2 motors? What sensors might you want on the robot instead of on an attachment? What motors do you plan on using? Many things like that. And so I haven't actually gotten to see the actual board, like in real life. I've seen images of it, and so looking at it, although you can get a lot done with 3, I think 4 will be important, but I think the 4th motor would go on an attachment that would help the robot for climbing. I don't think you need 4 motors to accomplish every kind of mission possible on the board, but it would be nice to have 4. So the general sensors that are used, the gyroscopic sensor is almost like very rarely never used, because it's a pretty sophisticated sensor to use for what people have time to program these things for. But they use touch sensors and light sensors, so we definitely want those too in our in the robot. We know we're definitely going to need that. We want this as our main moving motor, so the main thing that would do most of our tasks. 2 drive motors, because it would be hard to steer a robot with just one. The ultrasonic, although it's nice, it can probably go on an attachment, because we won't need it all the time. And as I said, since I don't have the expansion stuff, I will have to be using some NXT things that another kit should have, but I don't have enough of, so I believe that the kit actually comes with, unless I'm mistaken here, yes, it does normally come with 2 touch sensors, so I will have to replace, or not have to replace, but I'll have to add in a NXT touch sensor, so we have 2 of those. And although I said that the kits would be exactly the same, I may cheat a little bit and steal an NXT motor from another kit that we have here for the climber, but that'll be in a different video. So one of the things that I know that I do, and this is more of a experience / opinion based, not really like a here's why you should build it this way and because it's the best way. It's more like here are some ways that you can build a robot and some methods that you can use, and go out and build your own robots. Honestly, just remember, I mean, you can build this one. Hopefully there won't be anything wrong with it by the time we're done building, because I'm not building from plans. I'm just trying to keep some principles for building a robot in mind as I'm building this. So that's what I'm using to help me make this. So the first thing I think of is the size. Obviously I want it to be small, so before I even put any pieces together, I think, okay, what's the smallest way I can make this robot? How close can I get the motors here? Obviously the closest I can get these motors is like that, if I want them in the same direction. If I want them offset, I could kind of do it like that, but obviously that's not very practical for a robot. You could do it like this, because you can pin it right through there. But once again, that really doesn't help me in this particular situation. So honestly, I think that one of the simplest ways to get the kind of compactness that I want would be to have them put here together. And so I know generally that my motors are going to look like that. But now I start to look at the brain here, and I think, okay, well, what's the way I can fit the brain in here and kind of keep it short too, because nobody wants a top-heavy robot. If the robot's heavy at the top, it'll fall, because all the weight's up top and it's really high up. So like imagine trying to hold a 10-pound weight on a broomstick, and then you're holding the very bottom of the broomstick and you're trying to balance a 10-pound weight on the top. It's not going to work out very well, and you'll probably end up dropping the weight on yourself, which would not be very good. So looking at this, I think that if I can put it like this, that's pretty small. Looking at this from your angle, if you can put this motor right there, that's pretty small. You can probably get it smaller like that still. You also want to worry about width too, so I don't want a robot that's short but really wide, because that kind of defeats the purpose. Although sometimes it may be better to have a wider robot than it does a taller robot. But for this video and for the field that I could see just from looking at it, I don't think that height is too much of a problem. But width looks like it will be a problem. So I want to keep it narrow and kind of short, but not too short. So I think the best way would be to put these on like that. Now here comes the hard part, hard part. It's like I want them like this, but obviously when I let go, it's not going to stay there. So the next question becomes how? How do I connect this? And there are probably millions of ways you could think of attaching this piece to this with multiple pieces. I don't even want to think of the number, but some of the questions that should help you determine some of the better ways to do this would be strength. It needs to be strong. You don't want a motor that can move and wobble, because you're not going to get very accurate programming from that. It won't be consistent because the motor moves so much. When it shouldn't be moving, the robot should be moving on the field instead of actually just internally moving. So I know that I want it to be rigid. Depending upon your resources, since you have a kit, you want to make it as rigid as possible while using the fewest amount of pieces. You also want to consider style. Of course, that should. You don't want to make a really cool-looking robot that can't do anything, because that would, although it looks cool, it does matter how it functions. So just keep that in mind. And I know it's really hard to make that decision, because you're like, this looks so cool, but you're like, I really want it to do this, but you're like, man, that looks so cool. And most of the times you end up making the wrong choice there, and you end up going with cool, and then you're like, why didn't I make it the other way? But that's one thing to keep in mind. And the other thing would be, you always want the option to keep as many of these holes open, or at least when you fill one in, you want to at least replace it with another option to put a pin in. So an example of that would be, if I take this, just normal connector pin here, if I put that in there, what I've done now is I've blocked the hole. So if I put a beam on here, now I've covered up a hole, and I've lost that spot to actually connect anything else to. One thing that you can do to fix that is, instead of using this pin here, you can use, let's see here, where did I put these pieces? So I did sort these out. Here we go. You can use a pin like this. Now this allows you to take axles like these little hex axles that you put inside the motor. You can plug it into one pin here. Yours might be red. Oh, by the way, these might not be the same colored pieces that you have. As I said, mine came from different kits, so Lego has changed colors, and your EV kit comes with different colors. So if you're looking for like a piece that's, let's say, black, it's probably, and you can't find it, it's probably because it's a different color. Keep that in mind. And sometimes the colors actually matter. Like, for instance, the colors can tell you something between this gray pin here and this blue one. There are some pretty big differences between these two, although they're the same length, they're the same type, and they look almost identical, except for one. If I attach this here, if I put something I want to spin on it freely with no friction, like, let's say one of these things, and you check this with your kit too, because I know it's not going to show up, but I know I can get this thing to spin freely, and it comes on and off pretty easy. Now if I want something to be, but it also adds in there some play, and by play I mean it adds in more movement. It's loose, it's more loose than it should be. But if I add in this blue piece here and put this in here, it's not spinning. That would be because this one cares more about getting a piece to fit tighter, so it's not as loose, so it makes your robot rigid. It makes it very stiff, and it doesn't want to flex, which is really good. But it's not good if you want something to spin. So there are different colors. So normally the colors that will spin will either be a tan color, kind of like this, right here, or a gray one, and those will spin very well. Then the stiffer ones are black or blue, and there are some other colors, or red. Red's also kind of a stiff color that will fit in there. But tan and light gray are what will normally spin freely. Now your axles, the axles ignore the colors on them for the fit. The fit is always the same with the axles. The difference between the gray and the black are the length. So black axles are odd numbers, which means that this pin here, so if I grab a gray one and I cover up the holes and I count the holes it covers up, it's 1, 2, 3, 4, 5. This is 5. So this axle is 5 long, so 5 holes long. If I grab a black one that's really close to the same size, let's say this one, see how close that is? And I count it on this piece here. It's going to go 1, 2, 3, 4, 5, 6. So black axles are even numbers, or almost always even. The gray ones are odd. Now there are occasions where they do actually not matter about the color, but that's generally how it works. Is that the colors for axles represent the number if they're odd or even, but not always. But that's just something to keep in mind when you're building this. So, because you have a very limited number of, I believe the EV3 actually, the kit actually uses tan 3x3 pins instead of light gray. But I don't have those, or many of them, so I used gray instead. And it has a whole bunch of these blue ones, because the blue ones are for building, and the gray ones are for things that you want to spin freely, so keep that in mind. So now, after talking about that for probably what seems like way too long, we're going to finally build something. So I know I want my robot to be as close as I can together here. So I'm going to put these back, hopefully. Back. Oh. Okay, so first thing I look at here when I look at this is, for me, I'm OCD, so I really don't like odd numbers. So I don't like putting a bar here and then having one hole open. So that OCD is sometimes pretty good for Legos. It can also drive you insane too. So you have to find a good balance there. So if I did this here, you can see how that one hole is free and it's not covered by these two. It's free. It's like sitting like right there. So when I line that back up, that drives me insane. And I know that most of my parts are 3 long. Like for instance, this piece here. When I say 3 long, or I just use a number, it's like, oh, it's 3 long or 3 holes long. What that means is that most pieces, they're all evenly spaced, which means that when I put this piece over here like that, it's 1 and it's 1. Each pin is the same size as the width. So if I covered this pin here with this, it covers exactly 1 pin. It doesn't cover a pin and a half, it doesn't cover 1 pin and a fraction of one, it covers exactly 1 pin. So the width, so this length from here to here is 1 pin long, from here to here is 1 pin long, and that makes a square that is 1 pin long. So that's why I use pins or holes or just a number as the width or length, because that's, I'm not dealing with any actual like unit system. I'm not saying like, oh, this is 1 inch. No, this is probably like 4 pins. So an inch probably equals about 4 pins in Lego terms. So now that I've hopefully clarified hopefully now I made it easier for you guys to understand when I talk about numbers and you don't know why. Hopefully that'll make more sense. So now I know obviously I don't want one pin open because that's going to drive me insane, so I'm going to move it over one. So although I've made it bigger, I've given myself A, another place to attach something down the center, and B, I've kept it symmetrical and it'll work better for more parts sometimes. Sometimes having two hole spacing between the motors is good, but I prefer having even numbers because all the pins and stuff work out really nice and you don't have a really lopsided robot. So obviously, since I want to follow the rule of when I cover two holes up, I at least want to keep those, or when I cover a hole up, I at least want to have another way to attach it to that same hole. So it's kind of like you're not really covering it up, you're just extending it. So I know I want to do that. And so when I'm looking at this, I really like these pieces because what they do is they cover two holes up. They still allow you to put a pin into the center. But then they also give you the two option holes here, and it extends it out by one, but it also gives you another mounting place. So it's a really awesome piece because it also helps you change the direction of a pin. Like let's say, man, I really needed a pin to go this way, but my hole is this way. Well, you can plug that in there and then put a pin in there, and that solves your problem. So these pieces are really nice, and so I really like using them, so I'm going to end up putting these two here. And now I've kept my rule that since I've covered two up, I've also left two open. Or when I covered one up, I've left another one open. So now that I've done that, what ends up happening is I can put this here and that there. And I'm not gonna lie, last night I built a test robot, so I'm trying to remember this from memory. Of course, this could very easily fail, and that is a great possibility. So now you can see that this brick has many ways to actually be attached. You have 12 holes here, many holes here, and it's actually gives you many options that you may not realize. Since I know that I want to keep this thing small and I want to keep it rigid, I'm trying to use as few pieces as possible. I'm keeping in mind aesthetics, or the way that it looks, but I also want to make sure that it's rigid. So now that I have this here, I want to set this brick probably almost as close to this as possible. So when I look at this here, I hope I have this lined up for you guys and you can see. But when I hover this over these holes here that I can use to attach it to here, they're kind of shifted off by one, so they don't really quite line up. Because I want pins. The more pins that you have attaching a piece, the better. But it's also not a good idea to waste all your pins just attaching two beams together. So you have to find a good mix between that. So I know that I want to connect that there. So let's see here. So since I like even numbers, and it would drive me insane if it wasn't even, I'm going to connect that here. And once again, following my own rule of if I cover a hole up, I want to definitely keep it open again. You'll see me use a lot of these pieces. I really like these pieces. They are really nice. They're easy to pull apart, at the same time they're also not. I'm not sure how that works, but it does. It always works in the opposite way you wish it did at the time. Like when you want it to come off easily, it doesn't, and when you don't, it does. At least when you're building it. But then once again, I want to attach my robot here, and although I could just put some pins straight in here and connect it like that, and get the ability to put 4 pins in here, because previously I could have only gotten 2 pins, but I want 4 pins because I really want this thing to be rigid. I could just attach it like this, but since I built one last night, I know I wanted spaced up one more, and you will see why later. So I'm going to put these pins in here again. If I have enough, I should think. Actually, honestly, I don't know. I'm hoping I have enough. So that'll go on here. And so now you're like, well, that doesn't look very compact. And right now you're right, it doesn't. But you'll see at the end, it's actually going to be quite a small robot. And so here's what I mean, too, also by how it's not very rigid right now. It moves a lot. So we want to take as much of that out as possible. So now, I want to look at a way to attach. Well, first, I'm just going to simply just add a beam that goes right across the back of these motors here. And that'll help these line up better. Here. Yep. So for here, what I'm going to end up putting here are these. These are the ones that are 2 pins long, and you can put an axle in the back. And these are good for something that you want to take off easier, because it makes the pin wider in the section that you want to pull it out from, so you're not sitting there struggling to try and pull this pin out. So it gives you a good way to pull the pins out if you need to quickly attach. Sorry, if you need to quickly attach something. So I'm going to end up putting these. Once again, it's a 3-hole spacing, so I go pin, space, pin, space, 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 pin, space, pin. And that just so happens to match the hole pattern up back here. So I'm going to push this in. That's a little bit more rigid now. So now we can see it's definitely more rigid. But still, this is not. The NXT or EV3 is not rigid, so we want to fix that too. So, looking at this, and this took me a while to figure out last night, but I did it last night, so I didn't have to struggle through this right now. And this will help me demonstrate some principles to you guys here. Is I am going to use these pieces. So these pieces are unique in the way, because they have circle holes on all but one. This very last one here has a plus, and it's for the axle. The axle actually fits in right through here, and it doesn't spin. And so I can use this to hit things with, or to move, or use as a way to attach something to a motor. And so these are unique in that sense, that they offer a way to connect two of the two things that have those pluses together so they don't rotate like this. Because this piece in my right hand also has the same hole. So I can't rotate this, and I'm trying here. You can hopefully you can see it deflecting some, but it's not rotating. Whereas if I move it a single hole up, all of a sudden it moves. So that's what's unique about these pieces. They also allow me to get something really rigid by only using one connector instead of two. So, since I already cheated a little bit, I know exactly just about how far I want to space this apart. And by almost, I mean exactly. Now that I said that, I'm sure to mess up sooner or later. But until then, let's see if I can remember. Okay. Okay, so I am going to put this piece right here. And the reason I'm using this very long axle is, you'll see in a reason, or in a while, why I use this long axle. But I'm not going to push it all the way through yet. I'm just going to build one side, so for right now. And I messed up already. So what I'm actually going to end up doing is I'm going to put the axle through here. And I'm going to drop this back one more, like that. Then I'm going to get another axle like this. It's 3 long, and I'm going to push it through the bottom. Now here's the problem with just using axles instead of actual connector pins. So I can do that. But that'll be fixed here in a second. But although it's easy to pull out, it doesn't want to rotate too much. So it gives you a way to quickly remove and attach something, but it does not give you a good way to make a robot. So if it was all like this, you could just shake it and it would fall apart, probably. But I have that there. And now I have to find the right part. Where'd the part go? Part is... I'm trying to do this as best I can without just throwing pieces everywhere. No, not there. Or was it there? No, it was not there. And I did it again. It's there. So from here, what was I thinking I could get to? I may have messed up here. Oh yes, I do. I did. I think. Yes. No. Probably. I think where I messed up was right here. I don't believe I needed those. I needed pins. So sometimes, although it might be nice to have those pins that you covered up, sometimes you just don't need them, which this would be the case. So don't make it harder on yourself, obviously, if you can't add the pins that you just took away. Sometimes it might be better to not have them, but this should give me, yeah, 2. There we go. So this blue piece here is special. So there are 2 types. Once again, the color matters. If it's light, it's going to spin freely. If it's blue, it's going to be a tighter fit, which means I will get less play and it won't spin as much. So I'm going to use this blue pin, and I'm going to put it in the very end, which is a plus. So now this pin won't even spin, but it gives me a way to convert a axle into a hole. And then I'm going to use a lot of these little black single pins that connect. They're too long, and they're just simple pin connectors. I think I'm probably going to take that out sooner or later, once I'm all done and I realize that I shouldn't have put that there. But by that time it won't really matter. Because, no, actually I think that one was right. Okay. So, now that I'm here, you can see this motor now is quite good, but it still does this, still moves. But we'll fix that here in a second. So it might not always be obvious of how to make a robot rigid from the beginning, and to be quite honest, this didn't start out like this at the beginning. I built it, and then I realized once I was done, I was like, okay, I built it and I got to a certain spot, I wasn't done, and I was like, okay, well, I want to put the motor here. Well, since I had to put these pieces here, they were originally further down. I tried to get as small as I could, but then I realized I want the motor right here, but I can't put it there. So I had to lift this up one, and that's why I actually lifted that up, because the motor is going to go somewhere in here later on. And that's why this also isn't pushed in all the way, because that'll be used to hold it. But from there, I had to take it apart a little bit, change a couple of things, and then put it back together. So it never did come together perfectly the first time. I just realized a lot of things utilizing some of the things I've already told you guys. Use as few amount of parts as possible. Keep it rigid. Keep it simple. Keep try to use as few parts as possible and connectors, but make it rigid. And lastly, worry about looks last, and make it practical first, because if you have a robot that looks nice but it doesn't do anything on the board, I think you would have wished that it rather had done everything on the board instead of look cool. So that might just be my opinion. Well, no, actually that is my opinion. But I hope that you guys don't have to figure it out that way, and you'll just take my word for it. But I'm trying now to remember. I'm stalling right now. What did I do next? Right there. Okay, next I did something. Oh yes, I think I remember what I did next. Yes. Okay, so now on the inside here, remember how this the pin, this guy right here, could come out before like that, and that guy could too. So what I'm going to end up doing, and this is like one of the things where you realize you can make it better. I'm going to take this out. I'm going to grab a blue or black, whichever one you have. Either way, I want one that's a friction fit. It's going to be a 3-long pin connector. I'm going to put it through this hole right here. And I want one sticking out the other half of this, and I want one sticking up. And so I'll do that, and then I'll put my piece back on, and then I'll press down. And now, all of a sudden, I can't take it out anymore. So it's stronger. I can, just requires quite a bit more effort, which is good, which means it's getting stronger. Sometimes the piece just gets stuck, and you wish you could get it out. So then that snaps on there, and then that becomes a lot better. So now the reason that we put that pin there is you can see now we have 2 pins here that we can attach something with. So I'm going to try and remember, yes, this. So now that I have this here, before I duplicate it on the next side, I know that I want to use a light sensor. Now I'm going to try, I think I'm going to keep the original one, although I didn't like how it worked. The kit only gives you 1 light sensor, and it would be ideal if you didn't have to fix it solidly in one spot, so if you could like take it on and off. And I am going to actually try and attempt that. So I know I want to be able to use my light sensor for color and light sensor. It's both for more than just one thing. If you're wondering about the blue tape, it's just so my friend knows that these are his pieces. So I know that obviously my design had this in it at the beginning, so I know I'm gonna have to find a way to use that, but I know I can now just attach this then here. So you hear that click, so now the pin's also connected. And since the pin is connected here, I had a spacer that went, because here was my plan. It just so happens that when you keep everything spaced out 3, it just so happens that this can fit right here between the motors, as well as a touch sensor can fit right between the motors, and this motor can fit right between the motors. That's why I like making sure that all the numbers are even or odd. No, it would be even because there's not a 2 space, there's only a single space between this and these. So once I've done that, and I got this here, going to swap this piece here with this one, because I want this this little pin connector right here. So with that, get two of the 3 long pin axles here. Do that. I'll put this in right here. Come on. Wait, no, not yet, not yet. I was lying. I was just lying. What did I do for this? I ended up doing... gonna cheat a little bit here, you guys. Because yes, I did keep the old pieces. How did I do that? I did that like... That's all. Okay. So, what I actually did was this. I took one of these here. So this is a 6, no that's a 5, that's a 7. So I took a 7, and right here, I should have taken this out first. And I should have put this on first. This is all starting to come together, so I put that there. And there's a click. I know that you guys probably did not hear the click, but see right now, that's pretty rigid. Well, I know that I can also utilize this pin here to attach it to right here. I'm going to hold off on that for a second though, in case I actually need it for something else. So you can always come back and make it more rigid later, if you think you may need that pin later on. And I very well may. Honestly, I can't remember. But I know that I want my light sensor to be right about here. So that means I'm going to need this piece right about here. Which means that goes this way. Yes. Clearly well planned out. Just joking. Okay, yeah, and that hits the very bottom. Okay, yeah. And so, that's why I wanted to keep that open. It's because I'm going to put this here. So what that goes on each side. Okay. So I'm going to take my piece that I'm going to use to connect it with. I'm going to put that there. I'm going to grab another one of these. So these ones, the one that I just connected to, it's a little bit different. So I showed you that one, and then there's this one. It's a little bit bigger. It's one longer and one taller. So this actually kind of fits really nicely up right there. But then I'm going to connect this to the other side, like that. And then I'm going to need to fit this all the way right back here, like that. And I know I want to connect it with some pins here. And so that means this goes here, like that. This goes back here. And honestly, since I now know that this is going to be rigid up here, I can take this off and then pull the brick up, and the brick comes off, and now my motor is easy. It's really, I should have mentioned this before, it's really important that you can take your Mindstorm's the brain out, because the battery is important. Like if your battery's dead, instead of having to charge it, which you won't have a lot of time for at competition, it's a lot easier to replace the batteries than it is to charge it, so you don't want to have to disassemble the whole robot to get to the brain. But this will make it a lot easier for me to actually build this thing here. So That's going to go there. This is going to go right here. Like this. I also want a piece there. Of course, something I didn't just take into consideration is that if I have this here, I obviously just covered up the place where this fell into. So technically this is now sticking out one more than it should. So that idea won't work.